One of my favorite phenomenons in ancient history was Roman concrete, and for 2,000 years we had no idea how it worked, but we think we finally found out. Since Rome has become history, so a good while now, engineers, architects, archaeologists, and chemists have asked the question, how are Roman structures not only still standing, but in use today? The Pantheon is a great example of that, as it turns 2,000 years old next year. So if you remember in 2025, wish the Pantheon happy birthday. But you also have Colosseums, Rivieras, aqueducts that are every day exposed to rain and seawater, but showing little to no signs of eroding. Structures being completely submerged in water, being thrashed about in the sea, are still standing. And concrete is strong, it is durable, but modern concrete today starts weathering after 50 years. Our buildings made today aren't going to be around in the year 4000 due to eroding and collapse. Roman concrete was nothing short of invincible, and for 2,000 years we just lost the recipe. It was completely unknown. So here's what we know, and here's what we just found out. We knew some of the key ingredients, the big three being limestone, volcanic ash, and sand. They used a process called hot mixing, which is where they heated those three ingredients together and started mixing it. And when they added water, the mixture only got hotter and formed these calcium crystal grains that you can see in the Roman concrete. These white calcium grains are very visible to the naked eye, and for years archaeologists actually thought that that was a Roman mistake. Archaeologists thought that these little grains were a result of Romans poorly mixing the concrete, and if you know anything about ancient Rome, why would they make that mistake? But because of those crystallized grains, when water enters even the tiniest crack in Roman concrete, it starts to repair itself. When water gets into even larger cracks, if it touches one of those calcium grains, the grains dissolve in the water and then they recrystallize inside of the crack, effectively expanding and forming a seal or a patch. Roman concrete is only getting stronger with time. Modern concrete can't do that because it's designed to not interact with its environment. They didn't design modern concrete to necessarily respond to water because they wanted to prevent eroding. But it turns out, whether the Romans knew it or not, the secret to preventing eroding from water is to just absorb it rather than detract it. And now that we do know the secret behind Roman concrete, it is possible that more companies will implement calcium, limestone, etc. It would be more sustainable because the buildings would last longer and require less upkeep. Remember, there still are cons though. Roman concrete was notoriously hard to pour, and with a lot of modern designs, Roman concrete couldn't initially hold up those buildings probably. Remember, it gets stronger with time, not initially. But we can still experiment, put a mix of old and new, and see if concrete changes in the future anytime soon.